Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about how to take the derivatives of more functions, such as some trigonometry functions and e to the x and ln of x. So let's start with sine of x and cosine x. So to visualize the derivatives of sine of x and cosine x, let's say that Jackie is flying on a unit circle centered at x equals 0, and her angle theta is changing over time. Now, with some trigonometry, her x position is cosine theta, and her y position is sine theta. Now, let's say that Jackie is flying at 1 radian per second and flies off in a straight line, leaving the circle. Now, how far would she go in 1 second? The change in x position would be the derivative of cosine theta, and the change in y position would be the derivative of sine theta, because that distance traveled in 1 second tells us how fast x and y are changing. So Jackie is going to fly off tangent to the circle and perpendicular to this radius right here. And that means that if her x position is cosine of theta, the change in y is going to be cosine of theta because this is perpendicular, x turns into y. And the change in x, it's going to be negative sine theta. So that's how we get the derivative of sine of x equals cosine x, and the derivative of cosine x equals negative sine x. So now let's move on to the derivatives of e to the x and ln of x. So if you wrote out the definition of the derivative for e to the x, it would be e to the x plus h minus e to the x over h. Now, it doesn't really look like we can do anything from this, but we can actually change this up a little bit because e is a limit itself. It turns out that e is actually the limit as h goes to infinity of 1 plus 1 over h to the h. And if we change that up to be h going to 0, it turns into 1 plus h to the 1 over h. Now that means you can write the limit of e to the x plus h minus e to the x as this expression here. And now we can actually do some things with this expression. First, we're going to use exponent rules and split this up. Now we're going to factor this. And we can use exponent rules again because we're taking it to the power of 1 over h and then to the h. So that's just going to end up being to the power of 1. Now we have 1 plus h minus 1. We're just going to turn this into an h. And now we have an h in the bottom and the top, so we can just cancel those out. And we get 1 plus h to the 1 over h to the x. And remember, we're going to take the limit as h approaches 0. So this is just going to turn into e to the x. So the derivative of e to the x is e to the x. Now for ln of x, you'll notice that ln of x is just the inverse of e to the x. For example, the derivative at x equals 1 of e to the x, it's going to be e. But then you can map that to a point down here. The derivative at y equals 1 of ln of x is 1 over e. But we want to find the derivative in terms of x and not the derivative in terms of y. So that means that we need to convert x to y. Now, y equals ln of x. So if the derivative is 1 over e to the y, it's also 1 over e to the ln of x. And e to the ln of x is just 1 over is just x. So the derivative of ln of x is 1 over x. And taking the derivative of e to the x, it's the easiest thing ever because you don't have to change anything. It's Spirit's favorite number. So now let's do some practice problems to put together everything we've learned so far. Jackie is flying with j of x equals 2e to the x plus x. Find the slope of her flight at x equals 0 and x equals 1. So first we want j prime of x and e to the x. That's just e to the x. So it's 2e to the x, and then plus x. That's going to turn into a plus 1 in the derivative. So that's j prime of x. And then we want the slope of her flight at x equals 0 and x equals 1. So if we take this at x equals 0, 2e to the 0, it's 2 plus 1 is 3. And at x equals 1, 2e to the 1, that's just 2e plus 1. So that's 2e plus 1. Now for the second problem, Shadow is flying with s of x equals 2 sine of x plus 3 cosine x. Find s prime of x. Well, remember how to do the sine of x and cosine of x. S prime of x, 2 sine of x. Sine of x turns into cosine x, so it's 2 cosine x plus 3 cosine x. Cosine x turns into negative sine x, so 2 cosine x minus 3 sine x. Now, Gizmo is flying with the function g of x equals e to the x plus sine x. Find the equation of the line tangent to the graph of Gizmo's flight at x equals 0. G prime of x, e to the x, that just turns into e to the x, so it's e to the x. And sine of x turns into cosine x, so plus cosine x. And we want the equation of the line tangent to Gizmo's flight at x equals 0. So g prime of 0, that's e to the 0 plus cosine 0. Cosine 0 is 1, and e to the 0 is 1. So the slope of that flight is going to be 2. G of 0 is e to the 0 plus sine of 0. Sine of 0 is 0. So g of 0 equals 1. So that gives us the equation y equals 2x plus 1. And finally, Sunny is flying along the x-axis. Her x position as a function of time is x of t equals ln of t plus t squared. Find her velocity at t equals 2. So velocity, we're just taking the derivative of position. And we want x prime of t, which equals v of t. And the derivative of the natural log, it's 1 over x. So we have 1 over t. And from the power rule, t squared is going to be 2t. Now, at t equals 2, that's just going to be 1/2 plus 2 times 2. So that's going to be 4.5. And that's it for today. And I'll see you again next time.